Today we're going to move on to section 5.2. We're going to start solving quadratic equations by factoring. So before we start talking about it, we're going to define a couple words here. So a binomial has a prefix of bi, just like bicycle. Bi means two. So this is going to be an expression with two terms. So an example of that is x plus 2. So x is one term, 2 is your second term. That is a binomial. It has two terms. A trinomial then, well, tri always means three, triangle, tricycle, whatever. They've all got three. This is going to be an expression with three terms. So a trinomial might look like x squared plus 2x plus 1. We have three terms, x squared, 2x, and 1. Therefore, we have a trinomial. So when I say factoring, I'm talking about writing, if I could spell this would be a little easier, writing a trinomial as a product of binomials. So essentially what we're doing is the opposite of the foiling that we were doing in section 5.1. How are these going to look? We're going to factor x squared minus 12x minus 28. Well, we know that we're going to write it as a product of binomials, so it's going to break down into two. So I write two sets of parentheses, and I just leave them blank. And the number in front of this x squared is 1, which is nice. We like these. These come very quick and easy for us, and I can show you a lot of different tricks with those. So I ask myself, what multiplies to x squared? Well, the only thing that I can multiply to get x squared is x times x. So I put those in two separate sets of parentheses. So one in each of them. Now, I've got to ask myself, what multiplies to 28? Well, I've got a whole bunch of different, I got a couple different options here. I could go 1 times 28. I could do 2 times 14. I could do 4 times 7. So the question we need to ask ourselves is, which ones are going to let us get a 12x in the middle? One thing that'll help us do that is if we look at this sign right here. So I'm going to put this over here. If this is negative, this sign will tell you what signs go in your parentheses. So if it is a negative, it is always opposite. Opposite signs. If it is positive, or you see an addition sign there, so if it was 12x plus 28, then it would be the same sign and you're going to look ahead. And what I mean by look ahead is you would look ahead to the sign in front of the 12, and that's what your sign will be. But since we're dealing with negatives, we don't need to look ahead. It doesn't matter. They're going to be opposite signs. So pick either one in this case. One's going to be positive, one's going to be negative. 1 plus, 1 subtraction. And now we need numbers that are going to add to 12. Or to negative 12, I'm sorry. Well, the only two that would add up to negative 12 is if I take a negative 14 and a positive 2. Okay, you can try mix and match different ones. That's okay. You know, it's a little bit of trial and error here. But if you were to FOIL this out, you should get exactly what you started with. So you should always know if you factored correctly or not. And now that we've broken this down into 2 binomials, then we're done. Now, we change things up a little bit. This A is no longer 1. It's now a 3. So, the easiest thing to do, and the point that you guys are going to want to get to, because this will help you with things like your ACTs and standardized tests. They love to put questions like these on here, is where you start and you do that kind of guess and check method that we did here. So I could go 3x and x, same sign, look ahead, they're both negative, and I need factors of 10 that are going to add up to negative 17. I am going to choose 2 and 5, and how I check if I'm right on these is I know negative 2 and negative 5 don't add up to negative 17, but I'm going to check negative 2x, and this is negative 15x. Well, those two add up to negative 17. The difference is I've got that 3 there, so it gives me that 15x instead of just a negative 5x. So now, if you can get to that point, great. If that's the way that works for you, perfect. That is ultimately where we want to get to. But what if you can't get there? I'm going to give you another method. So this method here, I call it the guess and check. I mean, there's a strategy to it, but there's not. But really, for the most part, you're just kind of looking and you're not working your way through anything. This is what I call the AC method. This is one of a few different strategies that you can use to factor these. Some of you may have used slide, divide, bottoms up. That's fine. I know how to do that. I like this one a little better, just for the simple fact that it sets up some stuff a little better. So the key to the AC method is identifying what your A and C are. So A is 3, C is 10. So just like it says, we need to multiply A times C. So we're going to take 3 times 10, and we're going to get those to equal 30. The next step after we do that is we're going to find factors of 30, positive 30, that add to negative 17. So I get that negative 17 from our original problem. It's that B value. Okay. If you need to, go ahead and list out factors of 30. That's fine. You can go 1 and 30, 2 and 15, 3 and 10, whatever you want to do, 5 and 6. Go for it. The ones that's going to add up to 17, well, it looks like 2 and 15, but I can't use positive 2 and positive 15. So what I'm going to do is I'm going to use negative 2 and negative 15, because two negatives multiply to a positive. After I do that, I've decided which ones I'm going to use. I look at my original problem, and I'm going to almost copy it down exactly. The difference is I'm going to take out that negative 17. So I'm going to rewrite it as 3x squared minus 15x minus 2x plus 10. Okay, because this negative 15x and this negative 2x add up to negative 17, we haven't exactly changed the problem at all. Now what I'm going to do is I draw a line right in the middle of my problem, splitting the 3x squared and the 15x and the negative 2x and the positive 10. What I'm going to do is I'm going to look completely on the left side for right now. So I'm going to look at the 3x squared and the 15x. And I'm going to ask myself, what can I factor out of there? Or what divides 3x squared and 15x evenly? Well, the biggest thing I can take, 3 and 15 are both divisible by 3. X squared and x are both divisible by x. So I can factor out a 3x. And when I divide 3x squared by 3x, I'm just left with an x. So, and if I would distribute this 3x, I would get 3x squared. I keep my negative sign, and if I divide 15x by 3x, I'm left with a 5. Okay, that's good. Now we take a look at the right side. I ask myself, what can be factored out, or what divides negative 2x and positive 10? Well, a negative 2 can divide both of those. The reason I choose a negative 2 is because when I divide negative 2x by negative 2, I'm left with x, and I divide negative 2, or divide positive 10 by negative 2, I get a negative 5. The whole key to this is having this set of parentheses and this set of parentheses match exactly. Then all we do is we write the numbers that are outside of our parentheses. So I get 3x minus 2 and x minus 5. And if I were to FOIL that out, I would get exactly what we started with, which is exactly what I got when I did my quick guess and check method. So that's one strategy. If you don't like that, whatever, you want different ones, come talk to me. I will help you out with that, and we can get you there. And I can get you whatever method works for you. That's what we need to do. So we've got some different special factoring patterns. The first one is difference of two squares, which I call dots. Difference of two squares. I just abbreviate it, so if I write dots on your paper, for whatever reason, that's what I'm talking about. Then, perfect square trinomials, if you recognize that they're there, great. If not, don't worry about it. You can get to them through just regular factoring, and then you can just write it as like x plus 6 squared. You'd end up with x plus 6 times x plus 6. So it's not too different, so I'm not going to hit a whole lot of high points on that. The big one is the difference of two squares, where your first number is a perfect square, so a squared, or if we look at this example here, x squared, and your second number, in this case 9, is going to be, they're both perfect squares. Then all you do is take the square root of both of those, set them in two sets of parentheses. The only thing that changes is the sign in between. So x plus 3, x minus 3 in the example we have here. So, you know, it seems weird, but when you FOIL it out, you end up dropping that middle x term because it has opposite signs here. So it is kind of useful sometimes for us. So we're going to factor 4x squared minus 25. So what method should we use here? Well, I know 4x squared is a perfect square, and I know 25 is a perfect square, and there's a subtraction sign in the middle, so that would lead us to use difference of two squares, dots. So square root of 4x squared, and I always start with my two sets of parentheses. Well, what multiplies to 4x squared? Well, if I multiply 2x and 2x, and then Mr. Vigdahl said I need opposite signs, so I write down a plus and a minus, and ask myself, what's the square root of 25? Well, 5 and 5 there, and there is our difference of two squares. Those can get kind of fun because really that's all there is to them. All right. So here's 9x squared plus 24x plus 16. So because it's in this section, I'll show you how to do it using the pattern. So we've got our first number squared plus 2 times a times b plus b squared is going to lead us to a plus b squared. So in the example we've got here, we've got 1x and 36 squared. Well, b is going to be 6. And if I take 2 times 1 times 6, well, I get 12. So I get 2 times a times b. So how this works out, and again, if you don't like this and you just want to use regular factoring, I'm fine with that. But I just want to show you guys how this works a little bit. It is a perfect, this works into perfect square trinomials. So 9x squared, this is a squared, 16 is going to be b squared, and 24x has to be 2 times a times b. So how this works out is I find the square root of 9x squared, which is going to be 3x squared, plus, and I'll leave this spot. Well, I already know that my a value here, that is just a. So I'm going to get 2 times 3x and I need to find out what b is. Well, 16 would be 4 squared, and this is b, so that means in here I can get 4. If I take 2 times 3x times 4, well, I happen to get 24x, which is good. And then I can use this little formula back here, so it's a plus b squared because both signs are addition. If they're opposite signs, you're going to have a subtraction in the middle. But in this case, we have both positive signs, so I'm going to have 3x plus 4, that's a plus b, squared. Again, this one you can use your difference of square, not difference of squares, you can use your AC method, you can use guess and check, slide, divide, bottoms up, or whatever method you would use to regularly factor this if it wasn't a perfect square trinomial. So we, I'm perfectly fine with however you guys want to do those. That's all I got for you today. Let me know if you have questions. We'll get some practice with this, and we'll talk about this again tomorrow. Kind of show you guys how we're going to solve different stuff using factoring. So let me know if you have questions. I will see you guys in class.